I'm John Levine. I'm a product manager at Cloudflare, and I work on content delivery and performance. And so what I want to talk about are some of the challenges that our customers face delivering really low latency live video. And I want to talk about some of the ways that I think your CDN and Cloudflare can help. And I'm going to try to make this like 70% informative and only 30% sales pitch, or even less than that. I think everyone knows what live streaming is. So not video on demand. You're producing the content as it's being watched. And I think everyone knows what latency means, right? So glass to glass time, or like hand wave latency, right? When did the thing hit the glass of the camera and when was it watched on someone's phone screen? But low latency is a little bit more ambiguous. So I just, this talk was prepared weeks ago, right? This was stolen from the Mux blog. I think it was also borrowed from a talk by Will Law. So thank you, Phil and Will, for this. 1 minute probably does not mean low latency. But I'm also not talking about like, sub 1 second, like real-time communication, kind of talking about the sweet spot in the middle, right? So this is really important for a lot of applications. If you're doing OTT broadcast, if you're doing esports, something where maybe there's some degree of interactivity, like maybe a chat room, or you're competing with an over-the-air broadcast. But you're also trying to do this at real scale, right? You want to have thousands, tens of thousands, millions of concurrent viewers, right? And finally, you want a smooth playback experience, right? You're trying to balance, people actually trying to watch this thing without buffering and also having low latency. So before we dive in, let's talk a little bit about where latency comes from. If you've ever seen a talk on low latency live, someone's probably shown you something that looks like this, right? There's a camera, there's like an origin server where encoding happening, and there's a player. And this is really important, obviously. And most of these talks are kind of about that middle thing, right? How do you encode the video? Or maybe how do you make the player cooperate to make latency really low? And all that's super important. I mentioned Will Law did a great talk at DMUX last year. Definitely recommend everyone check that out. I want to talk about this a little bit differently because, I work at a CDN. So a lot more complicated stuff is happening on those lines, right? You have to get your video over the internet. That should really scare you, right? And so the internet's a scary place. And we kind of break this into two pieces, right? Ingest, getting from the camera to the origin server, and then egress or delivery from the origin server to a player out there. And we're not talking, a lot of these examples talk about, hey, I've like played it on one video player and it worked. But the whole point of like using a CDN is to get your video out to thousands or millions of people. And so things are a little bit different when all those people are trying to, watch at once. So we're gonna start by talking about ingest. We're going to break this into two parts. And so ingest is really hard, right? There's one camera, there's one server, and you're probably using a protocol that's not HTTP, right? Something like RTMP to get the video there. And from a CDN's perspective, this is not what we're good at, right? CDNs are typically good at getting HTTP traffic out to lots and lots and lots of clients all at once. So let's talk about what some of the actual problems here are in the context of live video. So there's really two different problems. One is latency and one is reliability. And they're kind of tied together, right? So latency is how quickly that packet gets across the internet, right? That makes sense. But reliability, what I mean by that is like the variance in how long it takes that packet to get across the internet. And if you're doing live streaming, you have to think about that variance, right? Because if most of the time it's fast, but occasionally it's really slow, you have to actually think about that slow case and be able to buffer for that because that's what's going to impact your latency at the end of the day. And so a lot of what we're going to talk about doesn't just reduce latency, but it just makes ingest more reliable so that you can bring down buffers and make your live streaming latency a lot faster. There are a lot of problems that can crop up. I'm going to come up with this kind of contrived example, something you may have seen before. So let's say you have a camera in San Diego, and you have your encoding server in US East in Virginia. And if you were to somehow shoot like a microwave relay across the country, it would go in this really straight line and would probably get there in like tens of milliseconds. But I think we all know that's not really what happens, right? Internet, like I said, is a scary place. And I think everyone knows the internet is a network of networks, right? So it actually has to hop between a lot of different networks to get across the country. And the way those networks communicate is using this thing called BGP. So maybe the path it takes might look something like this. And a lot of things can go wrong here, right? So the first problem is that like BGP doesn't really care about performance of your packet, right? If anything, it's really optimized for reliability and probably for cost of the network operators, right? So that they're not spending a lot of money to route your traffic around. And so there's a few problems here The first and obvious one is like, this is not a straight line, right? Like, just going to take longer. By the way, I made this example if I didn't actually run a trace route, but it might look something like this, right? But it's not a straight line, right? Like, you're not getting that direct microwave relay. You're actually going to take a lot longer, and that's just going to add time, right? And if you're thinking like, well, maybe instead of like 30 milliseconds, it's like 60. Okay, true, that can really matter. But what's really a bigger problem here is that these are like, this is physical infrastructure. Like all of those dots are routers, right? And all those lines are cable like in the ground somewhere. And so many problems can happen on each of those links, right? And again, the internet's a cold, scary place. Like if one of these links is congested, no one's there to help you, right? And a lot of bad things can happen, right? Probably in the best case, maybe some buffers build up in the network, throughput slows down, and hopefully you've built up a big enough buffer at your origin server to kind of deal with those events. And they happen pretty frequently. So what can a CDN do to help with this? So the main thing we fixed it, look, hey, it's great. So the main thing a CDN can do to fix this is CDNs have POPs all over the place. So there's a really good chance that there's a POP that's in San Diego or LA or whatever that's like 1 or 2 network hops from where your camera is. There's almost certainly a POP that's like co-located right with right next to Amazon's data center in Virginia, right? And so what that means is from the perspective of the camera from the source video, you can have this really direct, really well-established connection, and the POP can hold on to that thing for dear life and make sure it doesn't let go and make sure that connection is super fast and reliable. Same thing on the data center side. Now in the middle, this is where it gets a little bit trickier, but CDNs actually have a bunch of ways to make this connection in the middle more reliable, what's sometimes called like a virtual backbone. So one thing is there are a lot of POPs in the middle, so rather than just using BGP to like hope you get a route across the internet that's good, CDNs see a lot of traffic in real time. What that means is you can actually maybe pick to bounce between different POPs that don't have congested links or are pretty fast. Another thing you can do is actually select the transits between those POPs. So you're actually picking what routes you're taking to get between point A and point B. And the last thing you can do is you can just have your own backbone, right? So in a lot of cases, we just have dark fiber between POPs and we can use that, and we know those links are pretty reliable. They're not going to be congested. So great, this all adds up to not just reduced latency, but increased reliability, right? Less variance in your connections. And it means you can run your live stream hotter and you can bring down buffers across the stack. But so we've had this product for a long time at Cloudflare that does this, and a lot of CDNs do. Our product is called Argo. Typically it's called something like dynamic traffic acceleration, and we like to describe it as ways for the internet. And so I made a logo for Argo. Smarting BGP together, yeah. So this is pretty common. A lot of people do this. But the reason I'm talking about this here in the ingest portion is that we're working on something that I think is pretty interesting. So we're trying to bring Argo from L7 to L4. So what does that mean? So L7, L4, this is part of this thing called the OSI model, which is a way for networking people to sound smart. Okay, really what you need to know about the OSI model is L7 is HTTP, it's the application layer, and L4 is the transport layer, right? Like something like TCP or UDP. And Cloudflare is working on a product called Spectrum, which is trying to take all the smarts that we have at L7 and bring them down to L4, which is pretty cool. So this started really as a way to like defend against DDoS attacks or create firewall rules. But what we realized is that you can actually bring the traffic routing smarts to something like Argo dynamic traffic acceleration down to L4, which we think is pretty cool. So this is pretty early days. We'd love to get folks to try this out. So definitely reach out if you're interested in using this to improve ingest. So just to recap really quick, the internet is a cold and scary place. Getting bits across it is hard. And there are monsters in your way that can prevent your packets from flowing smoothly. And CDNs actually can help in this one-to-one case, not a traditional use case for them, but because they have this view of the internet and are really well connected, can actually get packets across the internet faster and more reliably. Great. So I want to shift gears a little bit. We've been talking about ingest and talk about the second half of that chart, which is about delivery. Okay, so how do we get bits from your origin server to the player, which is normally, again, what people think of a CDN as being used for. And so to oversimplify a little bit, the kind of key insight here about how this works is that everyone is talking HTTP. And CDNs are really good at HTTP, right? We're really good at caching files on servers all over the world. And then when people fetch those, they're just request response, right? It's a simple protocol. But kind of like I said before, like the BGP and core internet routing was not designed for low latency. CDNs, for the most part, weren't either, right? So it's a little bit more complicated. So I'm actually going to go another level of detail into how these low latency protocols work. So typically people use something like CMAF or LHLS. And basically what this means, what they're doing is you're taking your segment, which is a file, and you're splitting it up into smaller things called chunks. And that word chunk is really confusing because it generally applies to two different things. One is chunking at the sort of file level. So you're splitting, again, your segment file up into HLS or CMAF chunks. But it also refers to HTTP chunked transfer encoding, which has been in the HTTP spec for like 20 years. Basically means that you can start sending things without knowing how big the body is. And clients and servers and CDNs in the middle know what to do with that because that's been around a long time. So things work together to get live video across the internet faster because players can just take little sips of the file, right? They can read small chunks of it and they can start playing those right away. So I got this graphic, by the way, from a blog post by Theo Player. It's a great blog post. You should definitely check it out. So, okay, so that sounds good so far, right? We've split our segments up into chunks. That means we can start playing things really fast, right? Kind of. So let's look at this from the client player perspective. So let's say you're trying to play a video of a falcon. By the way, have people watched this video? There's some like falcons nesting nearby in Soma. They're really cute. Anyway, that's where I got the screenshots from. So anyway, so you have a falcon. It's like feeding its chicks. It's a live video. So you're trying to watch this video. You hit the play button on your laptop. And okay, so what's the first thing that happens? So your client's reaching out to the CDN and it's going to see if that file is in the cache. If you're the first person to get there, great. It's not in the cache yet. So CDN is going to speak HTTP back to the origin server and try to fetch that file, right? All just HTTP, really simple. And it's going to get that file and it's going to immediately start sending it back to the client. And that client's going to start decoding and playing the video because you've done all that hard work to use chunked encoding. And so far, so good, right? So great. The video's loading, it's playing, the cache is filling up. We're streaming that file all the way through. Everyone's happy, we're groovy. And then, lo and behold, like 6 more people show up and you're in good shape because that file has filled into cache and now your CDN can serve it super, super fast. The video plays right away, everyone goes home. Okay, it's a little bit more complicated than that, right? We're trying to do low latency live. And so what that means is in practice, everyone's going to show up at the same time and get that file, right? Everyone's going to come to you and request that file and it's not going to be in cache yet. So what do you do about that? Well, a really obvious thing you could do is just send all those requests back to the origin server, right? But then people wouldn't really pay us if that's all we did, right? If we were just like a dumb proxy sending all the traffic back. That's not very good. At least that would be fast, right? It might work for 4 people, but not like 4 million. And another option, and this is what typical behavior is, right? Is that you stream to that first viewer and that first viewer is happy, but everyone else just kind of waits and hangs out, right? So that first viewer, sometimes this is called like request collapsing, right? Because we're only making one single request back to the origin. But that first viewer really wins, and everyone else is just kind of sitting there hanging out, waiting for that file to finish getting cached before they can pull it in. So hopefully the way I set this up, the solution will be fairly obvious. We wanted to think about, we looked at this and we said, this doesn't make any sense, right? We need a better way to serve low latency live video to a lot of people without having some super complicated like push mechanism, something that just relies on good, plain old HTTP, right? And so we came up with this thing we call concurrent streaming acceleration, which is kind of an ugly mouthful. I'm open to better names. You'll probably guess what I'm going to show next. So remember, the problem is that you have all these people arriving and the cache is cold. We don't have the file yet. So what we want to do is we want to make a single connection to the origin server, right? People are paying us money to save bandwidth, right? But we want to stream the file back to everyone at the same time. So we can do this now. This is kind of amazing, right? So we went from the situation where everyone was requesting the file before and they were waiting to everyone's getting it at the same time. And so what does that actually look like in practice? So we turned this on for one customer and pretty proud of this chart. So this shows how much time at P99 a request spends waiting for other requests to finish in a live streaming scenario. And for this one customer, at P99, people were waiting like 1.5 seconds to pull that request in, right? And so the reason P99 matters is if you're watching like a 30-minute or hour-long live stream, like that's hundreds of requests, right? You're gonna run into this scenario. And so, a 1.5 second reduction here is something that can lower your live streaming latency from like maybe 10 seconds to like 8.5 seconds, which is pretty big. So we're really excited about this. So again, yeah, just to recap, we went from a situation where, people are trying to play the video, but they're buffering, they're just waiting, to a scenario where, they're actually able to pull that through in something close to real time, thanks to using, chunked encoding, CMAF, or LHLS, or something like that. Cool. So just to wrap up, like I said, I was trying not to make this too much of a sales pitch. We have this slogan at Cloudflare. Our motto is to help build a better internet. Our CEO likes to remind us we are helping. So you cannot buy a CDN and have your latency drop from like 30 seconds to 10 seconds. It just doesn't work that way. But if you're trying to get really low latency out of your live streams, hopefully there's a few things we can do to help and to really improve the performance there and make everything better. So thanks very much. Generally, the problem you have is when multiple people come and request a file, you actually have to wait for the cache to be warmed up. And so I made it sound pretty simple. Robert can explain it's a lot more complicated than this. Just the ability to stream that file out to multiple people while you're fetching it once from origin.